Alright, magnet to motion in 180 seconds. I'm about to make a DC motor make perfect sense, so if you've ever wondered how electricity turns into spin, this is your moment. Start with the cast: stator, rotor, commutator, brushes. Think of the stator as the calm friend who never moves. Its only job is to create a magnetic field. That can be permanent magnets or electromagnets, but either way, it's the stationary frame setting the rules. Now the rotor, also called the armature, is the troublemaker that spins. It's a shaft with coils of wire wrapped around it. When current runs through those windings, the rotor becomes a temporary magnet. So how does it actually start turning? You send DC power in through the brushes. These are springy contacts that press against the commutator, the shiny segmented ring on the rotor shaft. Current flows from your battery into the brushes, into the commutator, into the rotor coils. Boom. Those coils light up with an electromagnetic field. Here's the physics flex. A current-carrying wire in a magnetic field feels a force, Lorentz force. The stator's field pushes and pulls on the energized rotor coils. Forces on opposite sides of the loop create torque, and the rotor starts to spin. But there's a problem. If the current stayed the same, the rotor would swing into a dead spot and stall. That's where the commutator saves the day. As the rotor turns, the commutator rotates with it. The brushes slide to the next copper segments at just the right moment, flipping the current direction in the rotor coil. That flip reverses the rotor's magnetic polarity exactly when it would have lined up with the stator. Instead of getting stuck, it keeps getting yanked forward. Attraction becomes repulsion. Repulsion becomes attraction, over and over, all in the same direction. That's commutation, the secret loop that keeps the spin continuous as long as you feed it power. Quick recap. Stator, stationary magnetic field. Rotor, armature. Coils on a shaft that become a magnet when powered. Brushes, stationary contacts delivering power. Commutator segmented ring that flips current every half turn. Result, constant torque, smooth rotation. You can scale this up for drills and e-bikes, or down for little fans and toys. Electricity in, magnetic fields interact, torque comes out. That's magnets to motion, the DC motor way. If you got this far, you now understand the heart of a ton of machines around you. Next time you hear a whir, you'll know a commutator